Imagine a world where planes lose guidance mid-air, financial transactions are frozen, hospitals lose power to life-saving equipment, and people everywhere are plunged into darkness without warning. Chaos, panic, and looting could erupt in cities where electricity powers both information and order. According to a 2013 NASA-funded study, a storm like the one in 2012 could cost the global economy up to $2.6 trillion, with recovery time spanning a full decade. Unlike 1859, we are now hyper-connected, and that connectivity is our vulnerability. What's even more alarming is that we didn't see it coming in time. The 2012 near miss made one thing clear. While we have made strides in solar monitoring, we are still playing catch-up with nature's wrath. The sun does not operate on human schedules. It doesn't wait for our infrastructure to be ready. It simply acts. At Infinity Beyond, our mission is to uncover these warning signs and make them known. The 2012 solar storm wasn't just a missed disaster, it was a message. A reminder from the sun itself that luck is not a strategy. Preparation is the only defense. In the next segment, we'll explore how even minor solar flares have caused real-world incidents, from crashing satellites to triggering pacemaker failures on airplanes, and how, without visible warning, we are all vulnerable to an invisible threat from above. Because if a storm like 2012 happens again, and this time we're in the path, the world will change in a single day. The sun's activity doesn't just threaten satellites or power grids. It can also influence the most fragile systems of all, our biology and our health. Though we often associate space weather with technology, its reach is far greater. In recent years, scientists and medical professionals have begun identifying disturbing connections between solar storms and human physiology. Take, for instance, the case of Marie Moe, a cybersecurity researcher who experienced a terrifying episode in 2016. While flying to Amsterdam, she noticed her pacemaker began malfunctioning. Her chest muscles twitched involuntarily, and she felt an unnatural sensation. When she landed, the pacemaker's diagnostics showed that a crucial bit in its memory had flipped, a phenomenon known as a bit flip, likely caused by a burst of cosmic radiation. Though unprovable in a court of science, since such high-energy particles leave no physical trace, the incident is far from isolated. In fact, bit flips have been documented in everything from hospital equipment to airplane avionics. A 2008 Qantas Airways flight over Western Australia suddenly dropped several hundred feet, twice, injuring dozens. Investigators suspected a similar cause: high-altitude exposure to solar radiation triggering faults in the aircraft systems. At Infinity Beyond, we believe these stories reveal a haunting truth, that the sun's invisible hand can reach even into our bodies and our machines. Unlike lightning or earthquakes, solar radiation arrives silently, without warning, and its impact is increasingly being felt in ways we're only beginning to measure. But it doesn't stop with health. Solar storms have also played a hidden role in military history. Let's return to the Vietnam War. For decades, military analysts were baffled by the sudden explosion of underwater mines in Haiphong Harbor in 1972. These mines were magnetic, designed to detect ships, but no ships had passed. What caused them to detonate? Only recently did a study published in the Journal of Space Weather provide a clue. It pointed to a powerful solar storm that struck Earth at that time. A sunspot region known as MR 11976 had unleashed a series of solar flares and CMEs. The storm reached Earth in just over 14 hours, faster than usual, and may have tripped the magnetic sensors on the mines, detonating them prematurely. This revelation changed our understanding of solar influence. It showed that solar storms could, quite literally, change the course of war. And if they could impact military hardware in the 1970s, imagine what they could do to the global digital infrastructure of 2025. At Infinity Beyond, We examine these connections not just to raise alarms, but to foster awareness. If a solar storm can trigger a pacemaker, down a passenger aircraft, and sabotage naval mines, then what else might it do? The sun may be 150 million kilometers away, but it is not distant in its effects. In our next chapter, we'll turn to the skies, to the astronauts orbiting Earth, and those who will walk on the Moon or Mars in the coming decades. How vulnerable are they to solar radiation? And what would happen if a solar flare struck while humans were on the lunar surface? Because space exploration without space weather protection is a gamble humanity cannot afford. Imagine astronauts standing on the Moon's surface, carefully collecting samples, scanning the horizon, communicating with mission control. The sun is shining, space is calm, but suddenly, from 150 million kilometers away, a coronal mass ejection, CME, is launched with ferocious speed. There's no sound, no warning visible to the naked eye, but a storm is coming, and there is no magnetic field on the Moon to protect them. This is not science fiction. It's a scenario NASA takes very seriously. Unlike Earth, the Moon has no atmosphere and no global magnetic shield. When a solar flare or CME strikes, lethal radiation penetrates the surface with full force. In the case of a direct hit, astronauts exposed on the Moon would suffer acute radiation sickness, potentially fatal, in just a few hours without proper shelter. Long-term exposure increases the risk of cancer, organ damage, and severe DNA mutation. During the Apollo era, NASA meticulously scheduled missions to avoid periods of heightened solar activity. It was a calculated risk that, in hindsight, was extremely fortunate. None of the missions encountered a major flare. But future missions, such as NASA's upcoming Artemis program or proposed Mars expeditions, will face far longer exposure times, increasing the probability of disaster unless proper shielding and forecasting are in place. At Infinity Beyond, we explore these risks not to scare, but to prepare. Even aboard the International Space Station, ISS, which orbits within Earth's magnetic field, astronauts still receive doses of radiation far above what we experience on the ground. The ISS is equipped with heavy shielding, and crew members take refuge in specially protected modules when solar storms are detected. But what about deep space, or planetary outposts? This brings us to one of the great challenges of 21st century spaceflight: space weather prediction. A CME takes anywhere from 15 to 72 hours to reach Earth after an eruption, but solar flares, carrying harmful X-rays and energetic particles, travel at the speed of light. That means by the time we detect them, it's already too late. That's why early warning systems, like NASA's Parker Solar Probe and NOAA's space weather satellites, are so vital. These instruments monitor the sun's surface in real time, tracking sunspots and magnetic loops where flares are likely to erupt. But even with this vigilance, we still lack a comprehensive global alarm system, something akin to a tornado siren for solar storms. Imagine a future where astronauts on Mars receive a solar siren warning via AI systems that analyze solar activity in real time, giving them minutes to rush into underground bunkers or shielded habitats. That future is not far off. NASA is currently working on an AI-powered system called DAGGER, Deep Learning Geomagnetic Perturbation, which may one day give Earth and space travelers a 30-minute head start before a storm strikes. At Infinity Beyond, we believe awareness is the first defense. As humans push farther into the cosmos, understanding the sun's wrath will be as critical as designing rockets. Because in the vacuum of space, radiation doesn't knock. It arrives uninvited and unseen. In our next episode, we'll return to Earth and explore how geomagnetic storms have already disrupted entire regions, like the 1989 blackout in Quebec, and how power grids across the globe remain vulnerable even today. Because as we venture into new worlds, The one thing we cannot escape is the star we were born from.